Is we are talking about systems of equations, which means that every single equation that we have is going to have two lines that we're trying to figure out where they share a common point. Yesterday we talked about the possibilities of what they can have. We have one solution, we have zero solutions, and we have infinite solutions. Now, as we get into this, these problems are not just about random lines, they're actually good scenarios. So when you're trying to figure out, is it better to get this car at this price with this interest rate, or is it better to get this car at this price with this interest rate? You can figure out what the break even is. So like for instance for me, and this is going to be way over your heads I'm sure, but I just want to give you a real life example here. When my wife and I bought our house, we played what's called PMI. I don't know what PMI stands for, but it's basically you have to pay this additional fee until you own 20% of your house. And the whole idea behind it is they're trying to make sure that you do not just buy this house, destroy the house, and then sell it very quickly. Does that make sense? Now, by us paying that money up front, it cost us a lot of extra cash, where we could have just written it into the house and paid that extra bill every single month. Does that make sense? It was just what my wife and I decided. There's no good reason or bad reason. It's what we wanted to do. However, by us investing that money into the house early, that meant that we had to stay in this house for a certain amount of time before it would have been better to pay off these smaller prices or pay that extra tax. Does that make sense? You guys following me vaguely on that? Yes, Kate.
So it's like rich people buying
Good luck.
a house.
Thank you, sir. Thank you.
Rich people buy a house, what?
Like a goal, like you don't have to pay it off, they just pay for it.
Yeah, that'd be awesome. I
You still
cannot
have
do
to
it.
pay land tax.
If you buy the house outright, you don't pay anything.
Yeah.
I cannot do that. I don't have that kind of money. So when I did this, though, it put it into a break-even point, which is what we're essentially doing here. We're trying to figure out how many years do I have to live in my house with the extra money I paid up front versus when would it have been cheaper to just pay the bill every single month. And there's got to be a point where the numbers match up. Okay? Does everybody follow me so far? Now, with that being said, it's okay when we're given a line, we can manipulate the slope-intercept formula. What happens when you're given an actual scenario? So, for instance, the sum of two numbers is 26. Well, first of all, what does the word sum mean? What does that mean? Total what? Danny?
Total of whenever two numbers are added.
Yeah, so for instance, the sum of two numbers is going to be x plus y equals 26. Okay, are we okay with that? Why did I pick x and y? Can anybody tell me why I chose those as my Connor? Hayden, what do you think?
Put into slope intercept.
Yeah, if we use x and y, again, two unknown variables, then we can put it into slope-intercept form. How about this one? The difference of two numbers is 20. What does the word difference mean? What does difference mean? Connor?
If you subtracted.
Yeah, good. So what if I had x minus y equals 20? Are we okay with that? Does everybody see how I wrote these two equations? Okay, I'll take it to the next step after we practice a few of these. Number 2 says the sum of two numbers is 25. How would I write that one? How would I write that? Brian? X plus y equals 25. Is everybody okay with that? How do I write the second equation? How do I write the second one? Katie, what do you think?
X minus y equals 7.
All right, let me ask you this question. At this point in time, does it matter if I put the x before the y? No, because right now, those are just random numbers. They're just representing variables. The reason I'm using x and y is because it's easier to identify x and y. As we get more specific, obviously, the x will have a specific value and the y will have a specific value. But at this current time, we're just putting random numbers in. Understood? All right, try number 3. Just try number 3 on your notes real quick. All right, want to give me what they got? Colin, what'd you get?
I got x plus y equals 28 and x minus y equals 6.
Is everybody okay with that? All right, I'm gonna go ahead and scroll down a little bit.
Mr. Gabriel,
I'm gonna, yeah, what's up?
how are you getting like the number on bottom,
How am I getting the number on the?
so like x minus y equals
Because
20.
if it was like one value minus the other one. it
Because
would
you
be
see
the
in the
same.
equation it says the sum of two numbers is gonna be x plus y, and when it says it's 28, that's gonna be
Oh,
on the
wait,
equal
no, I see the
side.
other, I see the other number.
So the different. Oh, okay. You just weren't reading the
Yeah,
full.
yeah,
I got you. I got you.
Sorry.
No, you're good. I'd rather you ask, Ben. I'd rather you ask. Okay, we're gonna look at number 5. Now, number 5 changes a little bit. Okay? And this is just kind of the evolution of what we're doing here. And so, for number 5, it says Wally and Luke have $73 together. Now, we were using X and Y just a second ago, which was great. I have no issues using X and Y. But are there better letters that we could use to help represent this particular problem? AJ, what do you think?
W and L.
Yeah, so W representing Wally plus L, which is Luke, equals $73. Are we okay with that? Okay, let's drop to the next one where it gets a little bit more challenging now. Now we've got Luke has $5 more than Wally. Now, I'm not trying to trick you here, but how would I write that Luke has $5 more than Wally? JT, what do you think? You raised your hand. Zoe, what do you think?
Subtraction. So L minus W equals 5. Wait, if he has 5 more? Wait. What was it? Hold
I'm just proud of you for answering, Zoe.
on. Okay, thank you.
Carter, what do you think?
I think it's L minus W equals 5.
L minus W equals 5. What do you guys think about that one?
Yeah, that sounds.
Well, if Luke has $5 more than Wally, well, if we subtract whatever Wally has from whatever Luke has, isn't there a difference of 5?
Oh yeah.
What if I gave you a different one? How about this one? You weren't confident. I had to make you sweat it. Oh, that attitude. That attitude. I even tried to, you guys heard me give her the compliment too. So I'm just proud of your answering. And then she just shut down on me. Man, the hate is real in this one. What if we did this?
Yeah. Oh, that would work.
No, that wouldn't work.
Oh.
W plus 5.
Yeah.
How about that one? Or what if we did, do we agree that all three of those mean the exact same thing?
Yeah.
And let me just throw it out to you to verify. Let's say that Luke has $40. Okay, are we okay with that? I'm just making this up. I don't really know how much Luke has. I know they have 73 together, but let's say Luke has 40 minus W equals 5. Well, if I subtract 40, I have negative W equals negative 35. Do we agree that 35 is 5 less than 40? So do we agree that one makes it a true statement?
But can you just do it in your head?
Well, yeah, you can do all math in your head if you can.
Well, no.
I'm just trying to prove it to you. Now if we go over here, and let's say that Luke has 40 here. So now I've got W plus 5. Doesn't W still equal 35? So do we agree those are true statements, that they're both equivalent to each other?
Yeah.
What if I go over here, and I do 40 minus 5 equals W? Well, doesn't 35 still equal W? Yeah? Here's what I'm trying to get at. There's not always a right or wrong answer. We just came up with 3 very different ones. But they all produce the same exact information. The number one goal that we're trying to have today is we're trying to be able to set up these equations. Yours might look different from mine. Mine might look different from yours, but if they produce the same response, I don't really care. All right, here's what I want you to try. I want you independently to try number 6. Independently, I want you to try this one right here, number 6. All right, AJ, tell me what you got.
Alright, so L plus J equals 63, and then I might have mixed up the order on this, but J times 2 equals L.
L times 2 equals J.
Dang it, and my brain kept getting weird.
No,
No, you're right.
I was?
it's J.
No, because Lynn has
No,
twice
he's
as much
correct.
money.
He's correct because if you times J times 2, that will equal how much L has.
Yeah, but you
Yeah.
can do it the other way.
Yeah.
Yeah.
Sure.
Because if
So
you-
let me take over. Let me take over. Lynn has twice as much money as Joe. So if you take Joe's money and you double it times 2, doesn't that equal Lynn? Does anybody see a different way we could do this? What do you think, guys?
I did that same one, but I also did L divided by 2 equals J.
Don't we agree that if you divide Lynn's money in half, you would also get Joe's amount? Connor, what do you got?
the first thing I thought was J plus J equals L.
Yeah, isn't J plus J the same thing as 2J? He's not wrong. He's absolutely right. I love that he's thinking that and he's able to say that. But don't we agree it's still the same thing? Okay, so is this kind of clicking how you're writing these equations?
Yeah.
All right, I'm going to scroll down a little bit more. Let's get a little bit more complex, and then I'm going to show you kind of where we're going to end it for today.
Wow.
This is all going to be super handy tomorrow, but as of right now, we're just trying to address the equations.
Is this for mobile?
This assignment?
Yeah.
No.
Okay.
Maybe there's not homework tonight.
I think there is.
There is. We'll find out. All right, number 8. State College has 620 students. There are 20 more women than men. Okay? So, let's think about this one for just a second. I'm not here to go on a political rant, talk about gender. This problem setting, men and women, that's what we're going to base off of. Do you understand? So, how do I compromise, or how do I create the 620 students? What is making up the student body? The men and women, right? So, the first one's going to be men plus women equals 620. Do you understand how I created that? There had to be an equation, right? Something had to create the 620 students. The second part says there are 20 more women than men. So don't you agree that one's going to be women minus 20 equals men? Or couldn't we do men plus 20 equals women? We're all okay with that.
Yes.
Yes, Brian?
What do you do? Women minus men equals 20.
Absolutely. Women minus men equals 20. I got it. Thank you, though. How'd it go?
He forgot about it.
Okay.
Because well, he's actually in a meeting with the principal of my school.
Okay.
So
Okay.
we're just gonna reschedule it.
Cool. Sorry about that, man.
No worries.
Okay. We seeing how these equations are working. All right. I'm going to go ahead and stop my recording real quick. I think I'm just at about my time cap. And I'm going to go to your homework assignment.